I emailed this little these couple of pages of things to you in your inbox, so you can have a look on your own PDF as well. All right. So what did we say? We said that integration is also called anti-differentiation. Idea is that if I have a function and I integrate the function, then to get back the original function, I can differentiate. So they are effectively opposites. You can think of it as simply as addition and subtraction. We know that addition and subtraction are opposite operations, or they are inverse operations. The same is true for differentiation and integration. They are opposite operations. So moving along, if the differential of f of x is f dash of x, then what we're saying is that the integral of f dash of x would be f of x. If I were to differentiate a function and I got f dash, then if I were to integrate back f dash, I'm expecting to get back the original function. Basically, what is called the fundamental theorem of calculus. Now, that is not something that you have to memorize or anything, but it is what it's called. It explains the relationship between differentiation and integration. So the third point we made last day, an indefinite integral is actually an integral without limits. So the notation we're going to use is this sigmoid curve here, this sort of loop, and this is the integral operator. This is how we represent the integral with respect to x. All right, so the integral is taken with respect to x. So the fourth thing, exactly, the integral of f of x dx. This is your integral operator. Lastly, I did not name this part of the integral, but the function that we're integrating is called the integrand. Effectively, every time you're writing down an integral, you must have a function to integrate, which is called the integrand. We spoke about what is called an indefinite integral. An indefinite integral is without limits. Definite integration would include limits. So we'd have limits here, upper limits and lower limits. And it will allow us to actually evaluate the entire integral. For now, we are just dealing without limits. Indefinite integration. So the fifth thing, so we spoke about an arbitrary constant of integration. As long as we integrate indefinitely, meaning you're just writing down an integral, then we would not have limits. So what we would do is we're just adding an arbitrary constant c. The sixth thing, last day we spoke about, we're calling these integration theorems, but they aren't really integration theorems. The integral of a function that looks, with your integrand is k times f of x, where k is a constant. The rule is you could pull the constant outside the integral sign. The scalar multiple rule, if you wanted to call it that. And the second thing, the integral of f of x plus g of x would be the integral of f of x plus the integral of g of x. You integrate one at a time. We're dealing with the integral methods first, how to integrate polynomials, and then simple trig functions. And that's basically all we need to learn how to integrate for your syllabus. Applications, the equation of a curve, we said we have area under a curve and volume of revolutions. We spoke about a table of integrals. The first rule, a result from last day, the integral of a constant, a, is a times x. The integral of x to the power of n, where n is not equal to minus 1, is x to the n plus 1 over n plus 1. The integral of ax to the n is going to be ax to the n plus 1 over n plus 1. So effectively what I'm doing is adding 1 to the power, dividing by the new power. That is what this is saying for those of you who weren't on last time. So today we're going to spend some time going through this other rule. It is actually the integral of ax plus b to the n. All right. Now, what is this rule about? The function inside here must be a linear function, and it must be raised to any power. N is any real number. Basically, these things will take care of my polynomial integration, but we have simple trigonometric functions to integrate as well. For the simple trig functions to integrate, we are integrating sine and cos. All we have to learn is how to integrate sine of x. The integral of sine of x will be minus cos. You would recall that if I had to differentiate cos, the answer is minus sine. If I have to differentiate sine, the answer would be cos. If I had to differentiate this, I'm going to get that. So it stands to reason that if I have to integrate, I'm going to get minus cos x. If I have to integrate cos x, I'm going to get sin x. And we will get to that a little bit later on. We are restricted to just these functions here and these functions here, the simple trig functions. So number 9, basically, these are special integrals, all right? Trig functions, in particular, I put a star by this guy because I put a star here simply because this rule strictly is not on the syllabus. Strictly speaking, we don't have to integrate sec squared. These guys, sine squared and cos squared, very important, and we will spend some time proving it and going through how to. When we get there, we will do it. So this is all basically the remainder of this table we will deal with. Right, so as I was saying earlier, so we were speaking about this table of integrals. In particular, we are interested in this function, ax plus b to the power of n. This is our next vital, important function to learn how to integrate. Well, why do you need a formula for this? Why can't you simply expand every time? And I'm going to demonstrate to you why. Number 3, part B. The integral of 3r minus 2 all squared. What you would have done was expanded this thing and then integrated. What I'm saying to you is that we have a rule now. This is the rule. But do not forget to multiply by a. Of course, there's a plus c that you would always have. The integral of a linear function raised to the power of n is going to be ax plus b to the n plus 1, all divided by an plus 1. A is the coefficient of the x term. N plus 1 would have been a new power. The key point for this integration formula, this function inside of here is a linear function. All right, and it's in big. It's a linear function. Y equals mx plus c. That's what a linear function is. If the function is not linear, the rule will not work. The integral of 3r minus 2 squared dr. So the answer directly you're able to write down 3r minus 2 to the power of, add 1, right? So 2 plus 1 is what? 3 divided by 3. But then you have to multiply by the coefficient of r, which is just 3, plus c. So my final answer, 3r minus 2 cubed, all over 9 plus c. But you may ask, sir, what about if I expanded it? Why didn't I get an answer to look the same? So you get integral of what? And when you integrated this, you're going to get 9r cubed on 3, which is 3r cubed, minus 12r squared on 2, so minus 6r squared, plus 4r, plus some constant c. But if you recall my answer over here, it looks like this. 3r minus 2 cubed all over 9 plus c. So which is correct? Is this correct or is this correct? Which one? Both of them are correct. What accounts for the difference? If we expanded this, you would get something looking like your answer above here, but it would be off by a constant. The constant term I would get would be minus 8 over 9. Remember, this constant here would then be different from this constant here. This is perfectly correct to do it, expand it out and then integrate. But you are only able to expand this out because the power is nice and small. The power is just 2. This only works this way because the power is small. But what happens, or what becomes the issue if instead of 2, 5? I could expand it by multiplying it by itself 5 times, but it might take me forever. This rule is vital. The integral of ax plus b to the n is equal to ax plus b to the n plus 1 over an plus 1. If you forget the a times n plus 1, you're in trouble. The question will be wrong, the answer will be wrong. You can't get it right. All right, so these are the functions that we learned so far. What about these guys now? The integral of sine of ax plus b, where the angle, also called the argument, a fancy way to say the input for the function, to be linear. This angle is linear, it must be linear. Integral of sine of ax plus b, where the angle is linear, is going to be minus 1 over a cos ax plus b. The rule goes again, that's the integral of cos is sine x plus c. So it means that the integral of cos of ax plus b would be equal to 1 over a sine of ax plus b plus c. If you integrate sine of ax plus b, the rule is minus 1 over a cos ax plus b, minus 1 over the coefficient of the x term again. Integral of cos of ax plus b, 1 over a sine ax plus b. These are the most complicated questions that are really going to come. Example 24 here, right? Integrate sine 3x dx. Well, the integral of sine of 3x minus cos 3x on 3 plus c. The rule is that the integral of sine ax plus b is minus 1 over a cos ax plus b. So the integral of sine of 3x is going to be equal to 1 over a, in this case a is 3, cos of 3x times minus 1. And you leave an answer like that, is fine. Minus 1 to the cos 3x plus c. What about the integral of cos of x on 2? The formula says that the integral of cos of ax plus b is going to be 1 over a sine of ax plus b, plus c, of course. So in this case here, integral of cos of x on 2, this is my angle. The angle is really x on 2. The angle is linear. It's just is not written. Really, b is 0 and a is a half. But you don't have to write this like this to use the formula. So it's 1 over a is a half sine of ax plus b. So sine half x plus c. This is going to be 2 sine half x or x on 2 plus c. That's your answer. And then that's all for integration. You don't really have to learn anything else to know how to integrate. The aim is to finish everything. Again, by the end of the month, we'll finish up, and then we'll start with the paper ones and the past papers and so on coming down. All the meanwhile, those of you with outstanding SBs, I'll be calling you one-on-one. All right. So problems with anything, I want you to try this. I will send this on the chat again. All right. And you will do them for me, practice them, please, so that you are able to grasp what is necessary. Other than that, I would see you all on Friday at 10 in the morning. All right, people.